So, what is your aim to do?
Oh God, I got here.
After
Now you have linear polarization or what?
linear polarization I plan because my is LOS na.
Then why you need a polarization reconfigurability?
But it's achieving there now. I just want to check this one is coming
No.
or not.
Okay, I understood. If it is coming now, then advantage you are saying. Okay. Yours is linear polarization you are saying. And short distance you are saying.
Yeah.
Then why do I need circular polarization? It's waste of energy.
No, I want to linear polarized situation only.
Okay, linear in that no, Govind, you are not understanding. I am switching between linear polarization and circular polarization.
Okay.
Okay, wow. For circular polarization, I am checking this axial ratio.
No. Actually, what na for device to device communication now, many devices are this way. I take this phone this way. Another phone someone take this way.
Then that you have to do horizontal linear polarization and vertical linear polarization.
Okay.
For that it is not required. Axial ratio is not required.
Okay.
Okay, wow. Horizontal linear polarized waves. Vertical linear polarized waves. Okay, wow. For that it is not required. Here why I am checking axial ratio? I am going with circular polarization. For that I have to check axial ratio and radiation pattern and then surface current details.
Okay.
That is having separate procedure. So you say, if you want circular polarization, I will tell you what is the procedure.
But it's not required, like if it's
Short distance, it is not
indoor
required.
communication 2 to 5 meters is required.
For me it's required.
Okay, then we check.
Okay. For circular polarization, first you have to check axial ratio. Okay, your axial ratio should be less than 3 dB. For example, here mine I am getting from 5.7 to 6. Okay, 5.7 to 6 I am getting 3 dB less than, it is less than 3 dB. Okay, so here my frequency range is 5 to 7 gigahertz. But in this range I am getting 5.57 to 6 gigahertz I am getting circularly polarized, means axial ratio less than 3 dB. Okay, not only axial ratio less than 3 dB decides the circular polarization, other two conditions also it should satisfy. Okay, so here I am getting axial ratio less than 3 dB. Then what I have to do again, I have to check the radiation pattern.
Okay.
First it is like this. Okay, circular polarization, left hand circularly polarized, right hand circularly polarized. Left hand circularly polarized, right hand. First you study about this circular polarization, then only you will understand. Circular polarization, right hand circular polarization. So both are there. Which one we got, that we have to understood, that we have to find out. So for that I am checking here for this frequency, left I am checking. My left hand the pattern which is pointing towards upside.
Okay.
That is called your polarization. Here my left hand circular polarization LHCP it is pointing towards upward direction. So mine is now LHCP.
Okay.
My RHCP will be down. See.
Okay. So it's a left hand polarization.
If it is left hand circular polarization, then your direction of surface current should be in anti-clockwise direction.
Okay.
If it is right hand circularly polarized antenna, your RHCP will come like this.
Okay.
And your direction of surface propagation should be in clockwise direction.
Okay.
Okay, first you have to check the axial ratio whether it is less than 3 dB, and then you have to check whether the which
hand
your
polarized.
axial ratio, sorry, your LHCP, RHCP. And one more thing you have to check here, there should be 20 dB difference for this LHCP and RHCP. At least minimum 15 dB.
15 dB gap. So how, okay.
This null gap we can calculate. See here, I think I have some. See.
Okay.
This is 0,
Okay.
10, minus 20.
Okay.
This much difference
Mm-hmm.
we required.
Okay, okay.
Understood?
Mm-hmm.
So this is called, there should be at least minimum 20 dB difference between the LHCP and RHCP curves. Then only it is circularly polarized. Otherwise, it is not circularly polarized.
Okay,
And the surface current direction you have to check. For that you check my paper. In this paper I have given detailed thing.
Okay.
How the surface current should be. Okay, wow, see.
Current
My
distribution.
dominant current vectors. I have to see the dominant current vectors. So the dominant current vectors at 0 degree, my current is moving like this. Vectors are moving like this.
Mhm.
And at 90 degree, it is moving towards like this. And my around 180 degree, it is moving like this. And then at 270, it is coming like this. So total rotation, LHCP.
Okay, okay.
Okay, wow.
Oh.
So it is in clockwise direction.
Okay.
So like that you have to find.
Okay.
Okay, wow.
Okay.
Here in CST, how do you find axial ratio? Na? You have to check here post processing, cell template, far field and antenna properties, far field result. Here somewhere settings you go. Here you have to select realized gain. Here axial ratio. Ludwig 3 you have to select circular QOK. And then here axial ratio. You
Okay.
select like this, you will get, if you add it here,
Okay, okay.
it will automatically add. And
Okay.
it will come as a name, it will come in a different name, the directivity something. That you can rename. See
Okay.
here,
And
axial ratio like that you can rename.
for MEG, what we do? This one I think not coming for me.
Oh,
I check just then pattern reconfigurability now. Okay.
you
if
check
I-
if it is you are getting or not, I don't know, but you check. Maybe in future you can use this.
Yeah, that's one I use in future, I think.
For MEG, for this we cannot.
One simple example, this so now.
I have to check which one I have for MEG.
MIMO situation only we need. And sorry, that wide band equivalent circuit we design same way we can design.
Wherever you are getting the peaks, you take that frequencies
Yeah.
and
Then add the ports.
and then you optimize the values. I think
Okay, okay.
capacitance is the one we have to optimize for to achieve a wide band.
Okay, okay.
Either you have to increase or decrease. I think we have to decrease capacitance value.
Okay, okay. So first I use the
You
same
will
formula.
get like this.
Yes, yes.
It should come now.
Yeah.
You have to reduce something.
Mm-hmm.
Here I have or not, don't know what. Wait, I have to check.